Okay, now you look at the second question. And you've got three tables here that's given. And the variable, no, x and y, how x and y are related. So they're not the same equation. They're all different. You see, when x is 1, here y is 5. When x is 1 here, y is 4. When x is 1 here, y is 6. If you look at x is 3, you get 1, 3, 5. Here they didn't put 3. When x is 3 here, it's 2/3. So it's all because they're all connected differently. And they want to find out the expression, the rule, the formula connecting x and y. Have you got to it? If you got it right, great. This is a good sum. It sets you thinking because they didn't tell you that x varies directly or inversely. They just put that way. They didn't tell you anything much. They want you to find out. But what they did here is that they told you, hey, this is the findings. All right? So what we need to do is we need to get some tricks up our sleeves. I don't have sleeve. Up our sleeves and get to work on it. So let's look at the first sum here. Now we look at it. Your y. I shall keep the c here. I look at the a and I say, A, what's the relationship again? They've given us a few relationships. X and y. When x is 0, y is 0. X is 1, y is 5. X is 2, y is 40. X is 3, y is 135. We said, all right. There's a whole lot of readings here. So we said, y, you are equal to, it varies. Okay, it varies with x to the power of n. We don't know what's the power it's going to be. Because if n is a -1, it's an inverse variation. You know what I mean? If your n is a -1, it means 1 over x. If your n is a -4, it's 1 over x4. But if your n is 1, it's direct. Alright, so we put it that way. And even if you want to put a c, that's fine. Alright, you want to put a c there, that's fine. So we said, y, you are varying with n. We don't know what's your value. You can put a c there, a number, baby. So your y is going to be, okay, we put a k, x, n, plus the c, another constant. Let's say it that way. Now this constant can be moved out very easily when x is 0. Hey, y is 0. So we said this whole thing, whatever the x is, we're going to use all this information. We said x, when you are 0, you're 0. 0 times k is 0. And your y is 0. So automatically your c becomes 0. So when x is 0, y is 0. So we fit it in. Therefore, your c is a 0. We can fit from this equation. If you're not clear, let me write it down. 0, k, 0 to the power of n will be 0. So this whole thing will be a 0, and therefore your c is a 0. Is that clearer? Now that we've got the c, we want to find out who is k. Who are you? So we said, all right, when x is 1, x is 1, y is 5. So we said, okay, 5, y you're 5, x you're 1, k is, don't know, and your x is 1, 1 to the power of 5, sorry, 1 to the power of n, alright, 1 to the power of n, because your x, xn, your 1 to the power of n is always 1, so that's the beauty of 1. So you've got, your c is already 0, so your k is a 5, so that solves quite a bit. You said, alright, k is 5. Let's use the second bit of information. When x is 2, y is 40. So when x is 2, y is 40. So how do you go about that? X, you're 2. Y, you're 40. So your y is equal to k, which is 5, x, n. And your x is 2, 5, 2 to the power of n, and here is a 40. Bring the 5 over, 40 divided by 5. Ooh la la, you get an 8. And 8 is 2 to the power of n. And what is 8? 8 is 2 cubed. So you can see that your n is a 3. You've got that. So once you've got that, you can see the relationship. Therefore, your y, your k is a 5. Your x and your n is a 3. That's the relationship between your x and y. Let's fit it in and say, hey, hello. We talk to sum, you know. Alright, you can say you are k 5 x cubed. Let's see if it's true. When x is 3 cubed, 27. 27 times 5. What do you get? 135. When x is 2 cubed, 8. 8 times 5, 40. X is 1, 5. Everything is there. So that unfolds. And the information here, we're given this and we've got that. The trick is to say that we don't know whether it's direct or inverse. We said, hey you. Alright, we put this powerful equation there. Now let's look at the second part of the sum. The second part of the sum, how do we do that? Look at it carefully. We said, oh, look at it and said, y here, y varies with k, x, n plus a c. But we've only got 3 readings here. And it's not going to be very easy. We're going to find out whether the C is necessary to write. Maybe not. Okay. So if your y, sorry, when I put, look at my mistake. Do you all see it? What's wrong there? I've already introduced the k. So what should I put? Equal. Alright? Equal. Now, so if you look at it, y equals to k, x, n. Because I can say that y varies with x, n plus a c. Introduce a k there. Of course, this will just become a constant. So it's another constant. So we've already wrote that. And when x is 1, y is 4. So you get a k, and this is 1. We get a c. Now when x is 9, your y is a 12. Alright, x is 9. Now I would for the moment take off the c to c, make it less complicating. Let's look at that. Okay, because you can see it's a powerful number and we don't need to introduce sometimes a c. It's just a relationship between y and x. Now I made this decision because in the first case we had 4 things here and we could see that we got enough information. Here we've got 3 columns. Let's do this first and then we test it out. We put an n there because it can be an inverse or it can be a direct. Sometimes by adding unnecessary details. Alright, you're opening a Pandora's box of worms. So don't add unnecessarily. Until you cannot do it, then you go on to the next level. Okay? Now, so you've got when x is 1, your y is a 4. So 1 to the power n is still a 1. Your y is a 4. That solves it. So we can say, hey, Mr. Y, you are 4x to the power of n. And we need more details now. When x is 9, y is 12, x is 9. So we say when x is equal to 9, y is 12. We say 12, you are 4, x, you are 9, the power of n. Look at this very carefully. The n is only meant for x. We bring the 4 over. 12 divided by 4, you get 9, and I look at this again, we get a 3 here. And we can see it beautifully happening. Hey, 9, you're 3 to the power of 2, 2n. And what is this equal to? 2n is equal to 1. So what is n gonna be? Half. N is half. Because if these two are equal, the powers are automatically equal. Otherwise, how can the sum be equal? Alright, so 2n is 1, your n is half. So we said, wow, you can see that you found k, you found n, so therefore what can you say? We go backward here, your y is going to be a 4x the power of a half. We can say in other words, your y is a square root x here. Let's test it with this number to say if it's true. Alright, let me write this first here for square root x. When your x is 25, the square root of 25 is a 5. 5 times 4 is a 20. And that fits it well. Alright, so without unnecessary additions, a simple formula and everything works. Let's test again. When x is 9, square root of 9 is 3. 3 times 4, you get a 12. Ooh la la. When x is 1, square root of 1 is 1. 1 times 4 is a 4. So all that we needed was just this simple relationship, and we could find the value, the formula connecting x and y. Okay? Now, I hope you've got that clear picture. It's not easy to make an intellectual guess as such. You got to form using the relationship. The best thing is to write as x to the power of n. Alright? Because it can be inverse, it can be direct. Alright? It's just, you can see here it's a positive power, so it's a direct proportional. Okay, but just that it's a square root relationship, whereas here is a cubic relationship. Alright, let's look at this here. 1, 6. 2, you get 1.5 the y. And you can see that when x is getting bigger, y is getting smaller. Unlike here, when x is getting bigger, the y is getting bigger. When x is getting bigger, the y is also getting bigger. This is a direct relationship, direct variation. Here looks like an inverse variation, but we don't know the rule, and we only got 3 facts. So we said, alright, y varies with x to the power of n. That's the best to write. And then from there you go, if you're not able to solve it, then you go to adding another one more, c or whatever. Let's make it simple. And this can also be a direct or an inverse. As I said, if n is negative, then if it's x to the power minus 2, it becomes inverse. So let's find out. So y is equal to kxn. And now when x is 1, y is 6. Alright? So we can say, right, y, you are 6, and x is 1. X to the power of n, and your x is 1. Oh, beautiful. 1 to the power n is still 1, so your k is 6. So you said, alright, y equals to k, which is 6xn. We now need to solve what is n. So we take another part of it, and we said, okay, when x is 2, y is 1.5. When x is 2, your y is 1.5. So we say 3 over 2 equals to 6. And here's your k, your x is a 2 to the power of n. What do we do next? That's your x, 2 to the power n. Bring the 6 down. 3 divided by 2 times 6 equals to 2 to the power n. Now, my dear, simple division, doop, 1, 2, you get 1/4. Do you see that? So you get 1 upon 2 squared. So when you have 1 upon 4 equals to 2 to the power of n, and 1 upon 4 is none other than 1 upon 2 squared, which is 2 to the power minus 2. And you can see that your n is a minus 2. It's an inverse relationship. So therefore, what is the formula connecting it? Your y is equal to k, which is 6, and you've got x to the power n, which is a minus 2. Alright, your n is a minus 2. In other words, you can see very clearly, I could write it this way, 6 over x squared. That's what a minus 2 means. Do you see it's an inverse relationship? Beautiful. Alright, my dear boys and girls, fear no variation sums, please. Take it courageously. Take this special skill of y varying with xn, and from there you work it out. And we see a bit more details given. then you can put your xn plus c, your kxn plus c. Otherwise, you're limited and you can surely get your formula. All right? So this is a beautiful one. Look at it, you say, oh, direct. All right? What is it? Fit in your values and you've got that answer. In your question 1, you've got that. You look at it, we can find the c also because x is 0, y is 0. Oh, c is 0. We could find it very clearly. Now, and in this case, we said, all right, we don't want to create a Pandora's box. We don't want to open up. Make it simple. Let's try this. And it so happened it fits in beautifully with your k being a 4. And then we tested it and we saw your n is a half. That means your y equals to 4 square root x. And the last sum, you can see very clearly is an inverse variation. When x is getting bigger, y is getting smaller. Fit in your values of 1 and 6 and you get your k. And then take the next set and fit it in. And you've got your n. Your n is a minus 2. Now the third set is just to verify it. Alright, you got your y is here 6. Your x is a 3. 3 squared. 6 over 9. Reduce it. We've got a 2/3. Ooh la la. Wow. So there you are. We shall move on to question 3 and let's raise the level of difficulty. Keep on, keep it up, all right?